After studying this module, you would be able to know about total cost, total variable cost, total fixed cost, average cost and average variable cost. You would be able to derive the relationship between the short run average variable cost, short run average fixed cost and the short run average cost curve. You would also be able to derive the short run marginal cost curve, derive the relationship between the various curves that we have just discovered. Let us first consider what we mean by cost of production. Cost of production is an important factor while determining the amount or the quantity of output that should be produced and supplied. If the production cost is lower than the price or equal to it, then the firm would be in a position to supply the commodity. Firms which are not able to cover the cost would have to leave the market sooner or later. The cost functions are derived from the production function, and as we go along, we will be able to see that there is a dual relationship. That means cost forms the basis of production and production forms the basis of cost. They are, with respect to one another, they are the dual of each other. Of course, the easier way to understand it is to derive the cost functions from the production functions. Well, cost also depends upon other determinants such as technology, prices of other factors, the size of production, utilization of plants, plant size, efficiency, stability and so on. But here we are particularly interested in understanding the geometry and the algebra of how these short run cost curves are derived and how they are related to each other. The total fixed cost, as we know, in the short run is fixed, as the name suggests, because in the short run there are some factors which are fixed and the others are variable. So therefore, the cost incurred by the firm on the fixed inputs will be given, and this cost must be incurred. Remember that even if the level of output is 0. On the other hand, it also means that even if you increase the level of output to infinity, then the total fixed cost would remain the same. Therefore, apart from the variable costs such as wages and so on, there are certain items of expenditure of cost such as the overhead cost, rent, property taxes and machinery, cost of installing machinery and so on. So all of these costs are fixed in the short run. So if we look at the figure which is about the total fixed cost, then you would see that on the x-axis we have TFC, which is a fixed amount shown by the bracket. Then the total fixed cost line or curve is parallel to the x-axis, because we have just said whether the production which is given on the x-axis denoted by Q is 0 or infinity. Of course, no producer would be going to either extremes, neither 0 nor infinity. In the relevant range, we can say that when the output is Q1, Q2 and Q3, the total fixed cost will be given, which is given by the height of this blue line, which is the total fixed cost curve. Total variable cost. Variable cost is the cost of employing the variable inputs, the variable factors like raw material, labor, fuel, electricity, etc. The variable cost varies directly in proportion to the level of output. If the firm wants to increase the level of production in the short run, it can do so by employing more of the variable factor. So as more and more of the variable factor is employed, the output goes up. So these two are directly related, that is output and the variable cost. The total variable cost is the variable cost which is incurred on account of all the variable factors as we have mentioned earlier. The total variable cost, then we would see that it is related to and derived from the total product. The total product is an S-shaped curve, and so initially the total product, as we know, increases rapidly, then it comes to a point of inflection and then it increases further but at a decreasing rate. Now if we now look at the total variable cost, on the other hand, it is exactly the obverse of this. That is, when total product increases at an increasing rate, then total variable cost increases at a decreasing rate. When total product starts to increase at a decreasing rate, then total variable cost starts to increase at an increasing rate. So in between there is some point of inflection where the total product switches from increasing at an increasing rate to increasing at a decreasing rate. And parallelly, the total variable cost first increases at a decreasing rate, there is a point of inflection, and the total variable cost begins to increase at an increasing rate. Now let us consider total cost. Total cost by definition is equal to total variable cost plus total fixed cost. So we have just derived the total variable cost. Here what has to be done is that the are to be combined. How do we do it? We take the total variable cost and then we add the total fixed cost for each level of output. As we have already seen, for each level of output the total fixed cost is given. So we go on adding the total fixed cost, which is given as a bracket on the y-axis. So the blue line indicates that a fixed amount of total fixed cost is being added to the total variable cost and we arrive at the total cost. Therefore, on the y-axis we are measuring TFC, TBC and TC all in one, and on the x-axis obviously we have got output. So this is the derivation of the total cost curve. The total cost curve therefore is S-shaped. First of all, we consider the average fixed cost. The average fixed cost is the total fixed cost divided by the level of output, which is Q. TFC divided by Q is equal to AFC. Now let us graphically derive the average fixed cost. What we see is on the left hand side you have the total fixed cost, and the total fixed cost, as we have said, when it is divided by the quantity produced and supplied, would give you the average fixed cost. So as the output increases from Q1 to Q2 to Q3 to Q4, if you draw a ray from the origin which goes and touches a point on the total fixed cost curve, such as point A for the quantity being Q1, then what we could see is that the slope of this curve would have AQ1 as the numerator, which is the total fixed cost, divided by OQ1, which is the denominator, which is the quantity. So total fixed cost divided by quantity is height by base. So it is the slope of the line OA. Now, if you would notice that the slope of the line OA is higher than the slope of the line OB, which is higher than the slope of the line OC, which is higher than the slope of the line OD. Therefore, for each of these levels of output, if we trace and plot the average fixed cost in the next diagram, adjacent diagram to your right, you would see that average fixed cost is being measured on the y-axis and output on the x-axis. For the individual levels of output Q1, Q2, Q3 and Q4, the average fixed cost starts from a higher level and progressively goes down. Now, this has to happen in a certain manner. That is because the denominator or the measurement in the lower on the x-axis is the quantity, and when quantity is measured by the average fixed cost, it should always be equal to the total fixed cost. Therefore, we have to have a geometric property that at each level of output, the average fixed cost multiplied by the quantity should be always equal to a fixed number, which is the total fixed cost. Now, a rectangular hyperbola has got this property. Therefore, you would see that we have a curvilinear graph which represents average fixed cost. It is convex to the origin, and at each point the area under the curve would always be equal to the total fixed cost. So, if we consider this, then it would be obvious that A Q1 upon OQ1, which was the slope in the first diagram, would always be greater than BQ2 by OQ2 and so on. So therefore, this shows that progressively the average fixed cost goes on declining. In an asymptotic sense, therefore, when the quantity produced goes on up to infinity, then the average fixed cost curve will become parallel to the x-axis, although it will never actually touch the x-axis. Therefore, as we have said, the area under the curve will always be equal to the total fixed cost. So, what are we seeing? That in the long run, when the output goes up to almost infinity, then the average fixed cost becomes zero. It becomes irrelevant. Now, the relevant cost, therefore, is the average variable cost. How do we measure average variable cost? It is the total variable cost divided by Q. We go back to our total variable cost. The total variable cost curve, we said, is an inverted S-shaped curve. You consider a ray from the origin. The total variable cost, the height of the total variable cost is, let us say, AQ1 when the output is Q1. Now, the slope of this line OA will give you the average variable cost. At this point, you would notice that the slope of the ray from the origin OA is much higher than the slope of another line OB, which is corresponding to the output Q2. And therefore, what we can see in our average variable cost curve on the right hand side panel is that at Q1 the average variable cost is higher, at Q2 it is less, and it goes on declining up to the point of inflection. Now, we said that the total variable cost curve, it increases but at a decreasing rate, and at a certain point it starts increasing at an increasing rate. This point is point C. At point C, the output is Q3. Beyond this point, when output increases, then total variable cost increases at an increasing rate. So once again what happens is that to begin with, the average variable cost was high, it started to decline. At point C, it became the minimum, and once again it starts rising. So we have a U-shaped ABC whose minimum point is at Q3 and it corresponds to point C on the total variable cost curve. Average cost. Average cost is derived from total cost. Total cost is equal to total fixed cost plus total variable cost. If we divide by Q throughout, then average cost is equal to average fixed cost plus average variable cost. And average cost is equal to total cost by Q, average variable cost is equal to total variable cost by Q, and average fixed cost is equal to total fixed cost by Q. The average cost curve we are now examining in figure, and let us now look at the relationship between all the three, that is average fixed cost, average variable cost, and sometimes it is called average total cost. I would prefer to call it average cost. So let us now look at the derivation of the relationship between these three curves. Initially, average total cost or the average cost declines, and then it comes down up to a minimum point, and then it starts rising. Now corresponding to this, if you look at the average variable cost, it has also got a similar pattern. But the difference is this, that while the average variable cost still continues to fall for some time, the average cost begins to rise. This is because the difference between the average cost and the average variable cost is nothing but the average fixed cost. And the average fixed cost is initially high, but then after some point it starts to decline rapidly. So therefore, if you notice the gap between average cost and average variable cost, it is not parallel after the minimum point. So this is what we can see, that the average fixed cost monotonically declines and becomes parallel to the x-axis. The average cost, which is the summation of the average fixed cost and the average variable cost, is U-shaped, and so is the average variable cost. But the difference is that the average variable cost reaches the minimum point earlier and the average cost reaches the minimum point slightly later, and thereafter the gap between the two goes on reducing because the average fixed cost also goes on reducing. Now let us consider the marginal cost. Marginal cost is the change in the total cost due to 1 unit of production. So marginal cost is nothing but the derivative of the total cost curve with respect to output. And since the total fixed cost does not change with respect to output, so we can say that marginal cost is also the derivative of the total variable cost, since total fixed cost is irrelevant as far as the change in output is concerned. So let us see how we derive the marginal cost curve. In figures, again we resort to the total cost curve. The total cost curve is a inverted S-shaped curve. We consider the slope of the total cost curve, which is the marginal cost curve at different points. Let us say these points are A, B, C, D and E. The small blue line that you see is tangential to the total cost curve. Hence, it is the slope of the total cost curve. At A, you would notice that the marginal cost is extremely high. Then at B, it goes down slightly. At C, it goes down further. But after C, you would notice that the slope of this small blue line, which is tangential at D and E, sharply increase. So what is the pattern? Look at the right hand panel. In the right hand panel, you will see that at point A, the marginal cost is the highest. at point B it declines, at point C it declines further, but at point C, if you look at the left hand panel, you would find that the slope of that small blue line is actually parallel to the x-axis, which means the slope is 0. So similarly over here, C is the minimum point of the marginal cost curve, and here you would notice that the slope it is the minimum point, and therefore at this point if you look at the marginal cost curve itself, then we could say that at this point the slope of the marginal cost curve is 0. That means there is no further decline in the marginal cost. Whereas immediately if the output goes up and if the producer goes from C to D, then suddenly the marginal cost curve starts to rise, and this continues to happen as it goes along from C to D and D to E. So therefore, we have a marginal cost curve which is derived from the total variable cost, or you could even say total cost. Now, we have seen that average cost and average variable cost, they are related to each other through the total, the average fixed cost, and we have already seen that the average fixed cost is declining continuously. So now let us consider the relationship between AC and ABC. Both AC and ABC are U-shaped because of the operation of the law of variable proportions. What you see that the minimum point of AC is point D, whereas the minimum point of ABC is point C. This is due to the reason that AC comprises of ABC and AFC, and both are falling initially. With the rise of the level of output, both are falling. After ABC attains its minimum point at B, the corresponding to the quantity of C1, the average variable cost begins to rise. And between C and D, then what happens is that the rate of fall in the AFC offsets the rising rate of ABC and results in a continuous fall in AC. At a certain level of output, then the ABC also starts to rise, and so the gap between the two goes on declining. AFC by itself is falling and AC has already started to rise. So therefore, we see that the AC rises later, ABC begins to rise before that, but they are both U-shaped cost curves and they both have a minimum point. Only the minimum point of the AC arises later than the minimum point of the average variable cost. Now, if we look at the relationship between MC and AC, we again have to examine the total cost curve, which as we have said is a inverted S-shaped cost curve, and you would notice small blue lines which show the slope of the total cost curve, which is nothing but the marginal cost curve. Let us follow these small blue lines. It shows that the marginal cost to begin with is high because the line is steep, then it gradually falls up to a point which we have indicated by a perpendicular line, which is a blue line, and this is the minimum point of the marginal cost curve. Thereafter the marginal cost starts rising, as you would see from the slope of the blue lines. And now you consider the average cost curve. The average cost is the slope of the ray from the origin. I have not complicated the diagram by putting A, B, C, D over here, but you could imagine that we have 3 points A, B, C, D and E. So at A you could see that the slope of the ray from the origin is higher, at B it declines, and at C it declines further. So which is this point C? It is the intermediate point at which the slope of the total cost curve is actually almost parallel to the x-axis. So this shows that this is the minimum point of the marginal cost, and then if you look at the average cost also, after this point once again the ray from the origin, the slope of the ray from the origin begins to rise. So therefore we can conclude from this that the minimum point of the average cost curve and the marginal cost curve are both common. That means that the marginal cost intersects the average cost curve from below. That is, the marginal cost, if you look at the ray from the origin, the marginal cost is the slope of the total cost curve, which is above this ray from the origin. So conversely over here, the marginal cost falls faster. But after a point, the marginal cost curve starts rising earlier, and the average cost still continues to fall. And finally, we have a situation where the average cost rises slowly and the marginal cost rises fast, and it crosses the average cost curve and goes above it. So this is the relationship between marginal cost and the average cost. We can sum it up as saying, if the slope of the AC is greater than 0, then marginal cost is greater than AC. If the slope of AC is less than 0, then marginal cost is less than AC. If the slope of the AC is equal to 0, then the marginal cost is equal to 0. Now let us summarize the entire module. Fixed costs are those costs which do not vary with output. In the short run, we have variable costs and fixed costs. Variable costs vary with output because of the operation of the law of variable proportions. The fixed costs in the long run being fixed, the average fixed cost goes on declining. On the other hand, another phenomenon is that cost is the dual of the production. Therefore, if we have to derive the cost curves, then we have to consider the total product curve. The total variable cost is the inverse of the total product curve. It is the dual of the total product curve. And therefore, the total product curve is S-shaped, the total variable cost is inverted S-shaped. And from this, we can derive various relationships. We could see that the average cost curve is derived as a relationship between the rectangular hyperbola, which is the AFC, a U-shaped cost curve, which is the ABC, and if we add the two, then we arrive at the AC. And there is a peculiar relationship between the three curves. Similarly, with the help of the total cost curve, we can derive the marginal cost curve, which is the slope of the total cost curve. This is also U-shaped, and finally we have seen that the relationship between the marginal cost and the average cost curve is that the marginal cost curve declines faster, but it also starts to rise earlier than the average cost curve, intersects it from below and rises further. So these are some of the interesting facts of how production and cost are related and how we can derive the cost curves with the help of the short run production curves.